Hello, welcome for more Haskell programming. What are we doing today? So at the end of last week, I thought I'd finished the bytecodes for calling functions and returning from functions. I thought I'd finally got parameter passing sorted out. So then I tried to test it by writing a function which called another function. And that broke, and it wasn't actually because it called another function, it just uncovered a bug in the way it implemented some stuff. When I'm calling a function, I'm putting its parameters onto the stack, but when I return from the function, I'm not cleaning those up properly. So that's what I'm going to look at today. I hope my typing will be better today. I discovered definitively that I cannot cope on a tiny keyboard layout, which I tried last week. So I'm back to my normal, 42 key Colmac-ish layout. So it should be a bit better. It's more familiar for my fingers. Yeah, I did move some keys around, so I'll still have some issues, but hopefully it'll be better. But yeah, so the plan is to try and type well, and try and finish off the ability for functions to call other functions, or more specifically, for functions to clean up the stack when they return. I think I know I'm going to do that, but we'll find out when I implement it. If I manage to implement all of that, then I'm going to go back to looking at the compiler side of things. So there's two parts of this project. One is writing the bytecode based VM, and trying to write instructions to do various things or simple things like adding, subtracting, but more interesting things like calling functions and assigning variables. And on the other side, I'm trying to write the compiler so that we can write stuff in a higher level language and then compile it down to that bytecode. So if I get the function cleanup stuff working properly, I'll go back to the compiler side of things, because we have the new functionality of calling functions and assigning variables, and there's no higher level support for it, and it should be quite interesting to work through that. So we'll see if we get there or not today. Okay, back to the code. So I had this function last week, or this test, sorry, and it didn't work. And I guess I could kind of follow through what's going on here. Let me go back to plan. Just drop it into there. I'm going to clean up some of this crap, and we'll have a look at what's happening. This file is just full of things I've thought about at various times. Okay, so turning this into bytecode, first of all, we're going to start here and then define function A and function B. So calling A with 2 and 5 would require pushing 2 on first, and then pushing 5, possibly, could we do a round. Then we want to have our call, and at the moment call just takes a single argument, which is the address we're going to call, which I think is going to be 7, but I'll find out in a second. And then that's the last thing we do. So I'll put a halt in there to stop the program. So this is 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that's correct. Okay, so now we're into the instructions for this first function, function A. What that does is it has 2 parameters. So at the moment, I think what it does, I think it says load -1 to get X. And then it will call B with the next argument, so Y. So I think it calls load -2. I better check this in a second. Then it calls the next function. I'll need to count that out to see what that is, but I'll put the address of the next function there. When the next function returns, then it adds the 2 values together, and then we return from here. And then the next function, so B, it's going to load first argument. So I think that's going to be, it's going to be -1. And then it's going to push to value 2, and then it's going to add those together, and then it's going to return. So this call X is going to be, this is 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Just going to check that that's close to what I had here. 14, so I'm one off, but it was pushing those two, then call 7, and halt. Oh, it's not load -1, it's param1 and param2. Okay. We add special functions for these. Oh yes, of course, because I can't pass -1 in the word 8 because it's unsigned. So param is just a short, it's a special instruction to say basically load -1. But also it knows where stuff is on the stack. I guess that's kind of nice. So this is going to be param1, param1, param2, call 14. I better check the address of that. Let me call that, then I call return, and then implementation of B is load param1, push to add return. Okay. I'm going to assume 14 was right. Counting is too much effort. So those are instructions. So what we can then do is look at the stack throughout this, and particularly the stack pointer. I guess by extension the stack frame, see where that is. So the stack pointer is initially at 0 and the stack is empty. Then we call push 2 and push 5 onto it. So in reality the list is the way around, but I can just go from left to right because it's easier to write this out. So we push those two things on, then we call 7. Now at that point, I'd better check what the code is doing because I've forgotten a little bit from last time. If we can find step call, so what's that doing? It's updating the stack pointer to be the current position. So stack pointer, when we call it, is where it is there. Okay, so we're moving the stack pointer to there. We are pushing the return address onto the stack and the old stack pointer onto the stack. So old stack pointer first and return address. So the stack pointer is the address of the stack we were given, not the stack that we modify. The stack pointer is there, and then the stack now contains the old stack pointer, which was 0, and the return address, which is probably 5 or 6. 5. I think it's 5. Okay, so that's taken us up to this point. And now we go into this function. So remembering stack pointers there, we have, don't know why they indent that slightly, but anyway, we have 2 and 5 on this, on the original stack. Then this new stack frame has got 0, 5. And what do? We grab the two parameters, so that's 2 and 5. Sorry, it's 2 and 5, that way around. And then we call the next function. So when we call the next function, what we do is we set the stack pointer again. So we will, at this point, set the stack pointer to be here. And then we take the old stack pointer, which was, I guess, position 2. Depends how we count this. I'm going to count this as position 1 and then position 2. That's the old stack pointer. And then the return address, which is 7, 8, 9, 10, and 12, 13. Okay, so that gets us to the point where we're calling the second function. So now we will jump to here. And now at this point, okay, a bit long. At this point, we have this on our stack. So our new stack frame is really going to start here. And it says param1, so that's 5. 5. And pushing the value 2. And then it calls add, gives us a value 7. Oops, no, not that, 7. And then it calls return. So what return is going to do is it's going to use this to update the stack pointer. At this point, actually, this point, stack pointer is still sitting here. So when we call return, this becomes return address. So this only affects the instruction pointer. So we can kind of ignore it from the stack point of view. This gets used to restore the stack frame, and this last value in our stack is return address. So after we call return, we still have stack starting the same way, so it's 2 and then 5. Oops. And we still have the same things in our original stack because we haven't done anything with them. Now we take our return value, which is 7 in this case, and we push it on the end of the stack, the start of the stack, but in this diagram, the end of the stack. And we restore the stack pointer. So we put the stack pointer back to here. Addition 2, which comes from here. But this value 5, which we got to call this function, is still there. So when we call add, we're actually adding the return value from B onto the parameter we passed into B. So this is why we're getting 12 as a result, rather than the 9 that I was expecting. I don't know if I put commas in the first bit of stack, not the rest of them, but consistency is good. Consistently wrong. Okay, so this has still got 7, 5, and 2, and 5. So we're doing with, oh no, sorry, 7, 5, and 2. Then we're not in this instruction add, so we take the last 2 things off, we pop them off and add them together. Something that was 12. And then we call return. So when we call return, what we're going to do is take this value 12 and put it back on the end of the stack after jumping back. So the stack pointer goes back to the very beginning. In this position 0, we're back to the beginning. We then have our 2 and our 5. Let's not do that. 2 and 5, and then return value, which is 12 from here. This is an instruction pointer, which will point to halt next. This value gets, well, all of this stuff gets thrown away. So basically, we take out the last value, the return value, we take out the first value for the restored stack pointer, we take out this second value, which is a new instruction pointer, and then we just throw everything after the stack pointer away. So now we're left with this, and then we call halt, and all halt is going to do is take the last argument and return it. And that's wrong, because it should actually be 9. So, problem comes, you can see it most clearly with this first return. So when we return from here, we want to wipe out this thing. And there are a couple of ways I can think of doing that. But they both involve knowing how many parameters are being passed in. So when we have this instruction, like call 7, I think actually it's going to have to be call 7 and 2, or 2 and 7. One argument is a number of parameters, and the other argument is this we're calling, which will increase this by 1 because we've added an extra parameter in here. And then at this point, when we're calling our next instruction, we're going to pass in the number of parameters, and then we'll just update this to 16. Because now we've pushed it along by 2. So that will let us do two things. Either we can remember its value. So when we pop at this point, we would need to put an extra thing on our stack, which is like the number of parameters. And then when we pop, we would say, okay, and it also pop this many things off this stack. But that's a little bit inefficient. I think what we could actually do is the point at which we say call, we can say the new stack pointer is this position minus the number of arguments being passed in. So actually in this case, the stack pointer wouldn't move, it would stay there. So when we call the next function, the stack pointer does not get set. Oh yeah, so conceptually as well, we can think about the stack frame as just continuing now from this position to the end. So now when we call our next function, so we push our stuff on here, call our next function, the old stack pointer is 0. And we can think about the first frame is ending here because our new stack pointer is going to be, let me split this up a bit. So this is where we are when we're calling the function. This is where we are when we're calling the function. So we had 2 and 5 got pushed on originally. Then we do our call. So I'll need to worry about this a little bit. I might need to reorder things a bit. But anyway, we have our call, which is the old stack pointer and then the return address. And then we come into here and then we grab the parameters before we do the next call. So we grab the parameters, which would be 2 and 5. We don't actually need to do this anymore, do we? Yes, we do still need to do this. Okay, so we grab the parameters 2 and 5, and then we say call with 1. So what that's going to do is move this back by 1 effectively, and then do the call work. So that's going to put the old stack pointer, which was still 0, onto here, and then it's going to put the return address, which is 13. Possibly it might have changed a little bit, and it's going to set the stack pointer to here. Okay, and then when we evaluate this function, let me get rid of all of these. When we evaluate this function, we're now in this stack frame, and it says parameter 1, so we're going to take a copy of the value 5, and we're going to push the value 2. Then we're going to add them together, which gives us our 7. Then we're going to call return. Now this gets a little bit tricky, I think, because return doesn't know how many parameters we have. So it might just do a little bit of reordering. So anyway, 7 becomes our return address, so that's nice and easy. So when we return from that function, 7 will get pushed onto here. 13 is instruction pointer, but I don't know how we find that because we don't know how many parameters are passed into the start of this. So ideally, what I'd like to do is reorder stuff when I call. I'll keep following this through. Imagine we can get the stack pointer and the instruction pointer back. So stack pointer is 0, so we put it back to here. And the instruction pointer is 13, which imagine we got it, and then we just throw away this whole frame. Okay, and if we come back to do this return, we come back to here and we get the next thing we see is add. So this will be 2, 5, I guess 0 is still there, 5 is still there, but then it is going to pop the two things off in the stack them together. That's going to give us 9, which is the correct answer. That's nice. Then we're going to call return. So what return needs to do is update the stack pointer, and it's actually going to still be 0. It's going to grab this for the instruction pointer, so it'll point to halt. I'll grab this as return value. So what we should end up with is a stack that just contains 9, and the stack pointer will be sitting here, which is a much better outcome. The problem is, how do we skip over these parameters? So we could add an operand to return, which says return and you had 2 parameters, but it seems wasteful to repeat this value over here. Because what I could actually do is, if you say call 2, call could be something, so call, I'll just call it end for the number of parameters, and then some address. We don't really care about the address part of this. So call n could say, internally, we could input this as pop n, but remember the values. So maybe I'll call this take n. Then push the stack pointer, push the return address, and then push the result of taking n. So you can say, I don't know, like params. I've moved equals to there. We could say push the params. Something like that. I'm going to turn off spell checking. That's a bit annoying. So what this would then do is, when you get to this point, you say call 2, it'll pop the 2 things off, 2 and 5, push the stack pointer, push return address, and then put these back on again. So we end up with that, which I think makes more sense, because then you always know where those, you always know that the first element is the old stack pointer, the second element is always return address, and then everything after that must be the parameters. So if you say param 1, it goes to your stack pointer, skips the next 2 elements, and then grabs that next thing. So when we call this thing, it'll actually pop one off, put those two on, and then push it back onto the stack. So we would get this, which means return can still do the easy thing of, or the easy-ish thing, getting the return, getting the old stack pointer, getting the return address, getting the last thing off here, which is return value, and then just throwing this stack away, this frame away. This will still be the other way around. Yeah, and then when it goes 05252. Nope. But I don't really mind that so much. We don't need to optimize this at this point. Zero 5252. I might have typed this. It may be supposed to be 25, but irrespective. I think the point still stands, so it works basically. Okay, so I'm gonna have to rewrite call. I'm gonna maybe have to add something for this functionality. I'll need to be able to pass in an extra operand for call. And I'll need to rewrite parameter loading. But they're all easy changes. Right? So first thing I'm going to do, I guess, is we're going to change the instruction call from being a unary to being a binary, which we don't have. I might just rename these. And notice my language server's kicked in again today, so it's now suggesting a whole bunch of changes. Let's just go with it. Oh good, it did not work. It's going to complain at me but not actually fix anything. Okay, so unary I want to rename to be unary op, I think. Sorry, nullary I renamed. Unary will be unary op. And then we can have binary op. And it's going to be very similar. So it's going to take a function which takes two word dates. And the CPU and return something. It's going to take the program and the CPU and return the new CPU, which is a result of calling this new thing. So binary op, given some function, I'm going to call the program, and yep, we do need the IP. So it's going to be CPU at CPU. There you go. I almost looked up the IP from there because that's the thing we actually need to increment. It'll be function. I guess we could call it V1 and V2, or X and Y, or V and W. A new CPU. Where? Okay. So V, I can do this in one go. No. V is equal to same thing. So pbang, and then it's CPU IP +1. And W is equal to bbind CPU IP plus 2, and the new CPU, the old CPU, oops, is equal to the old CPU, but we're going to move the instruction pointer forward by 3 this time, so 1 for the operand itself, and 1 each for the 2 arguments. Okay, so now we can change call to a binary op. And then step call can have 2 arguments. So we've got word 8 to word 8 to that. So what are the 2 arguments passed in here? The first argument is going to be the number of params. The second argument is going to be the call address. I didn't call it call address because we want to use it from integral here. Doesn't really seem worth it. I just call it call address up here. And then here I can just say from integral. Ditch that. Okay. So the new stack is not quite as simple as it was before. So we want to do we want to get 2 values off the stack. So we can say something like params and this is going to be a tuple because it's not go anymore. The params themselves and the stack without the params. So we can call this CPU stack prime. Not a big fan of calling everything prime. I get confused later. But the params and the CPU stack without params on it, it's going to be something like s.take, and then we'll give it the number of params. Which I need to go and write. And then it's going to be new stack is going to be pushed onto there. So we take our stack without the parameters, we push the stack pointer and then return address onto there. And after the return address, we want to join it to the params. So we will say that. Okay. So the stack push pop take a pop n take. So take is going to go from it's there. Oh, it's going to need a stack. I forgot to pass the stack in. It's going to need the number of things to take. Looks like I'm passing that through first. So the number of things to take, the stack itself, and then it's going to be, oops, either error or it's going to give you back two stacks. It's basically splitting the stack. So the first argument will be the things that took off, and the first return will be the things that took off, and the second return will be the remaining stack. Oops. So we can say take the number of things to take and stack S, and we'll just chuck in a guard here, I think, and we'll say if n is greater than the number of things on the stack. So I'm going to do so n is greater than the length of the stack. Is going to be a throw error, and it's not empty stack, it's not enough elements in stack. Otherwise, so if there are enough things in the stack, then what do? We would just take n s, and it's prelude.take. Kernel assertion failed. Good. Okay, so that should be the implementation of take. So that's all good, I think. And then the next thing we needed to do was update params with a param command. So down the back of find. Okay. Oh, we have a problem here, sorry. So it's take num params from the stack. And the new stack pointer, I'm going to move this to top, because the new stack pointer is actually from the modified stack, not the original stack. So if there were two things on and we call something passing two params, the stack pointer stays at 0. Okay, so, oh no, it didn't give me an error. At this point, what's happening? I know what I was confused by. The reason I thought of this is because num_params should be from integral, because here it's a word 8 and here it should be an int. So I think something has gone badly wrong. Let me just jump to the errors and see what. Oh, yes, okay. Calling it take is not a good idea. Let's call it pop n. Okay, getting a bit better. Oh. These are the errors that I want. Okay, so this is going to be pure that thing. And it's not take, I guess. That's not what I want. Maybe it's split, so I'm going to look up a second. And the problem here is, show me that error again. Can I actually set T0 that's stack, so I can't take the length of the stack. Yes, so I might to destructure this. Somewhere else I checked the length before. Yeah, so I destructure it to stack S. Okay, Same problem now is take is not the function I want. Does it work? Yes. So we want to go from an int and I guess a list of A's, and I want to go to a pair of list of A's. Second one, there we go. Split that. It's split out that I want. Turns a tuple where the first element is x's prefix of length n. Exactly what I want. Okay. Where's my error? So I want stack and I've got int. So it's not quite that. Where? Okay, so now we want params. It's going to be tuple, isn't it? So params and the rest of the stack. I might just call it as prime. That's equal to this split at. And then we can just return tuple here, where it's stack params and stack s prime. Okay. No, it's not s.take, it's s.pop n. Now we get the error that I wanted. Okay. Like not wanted but expected, so this should be from integral. No. From integral, and we'll pass it number of params. And then that. Okay. And okay, we can't do that. So this is gonna have to be do. I will drop that into there, and it's actually going to come from that thing. Okay. So all my where stuff is going to break down now. These are going to have to become lets. Okay, and then it should have noticed now that there's no monolith instance for params. Not quite. Maybe it is. Couldn't I expect a type s.stack to s.stack with actual type s.stack in the first argument of whatever that's called? But there isn't. I'm a bit confused because there's no semigroup instance for params, so I expected that to be the error. Is it because I need to bracket this? It is not. Oh no, it's better. No instance for semigroup S stack. That's the error I wanted. Okay. Instance semi-group, is it like that? Stack where it is not like that. Maybe I meant semi-group with a capital G. Okay. And then, do we say that? X and Y, and all these structures as we go. So stack X and stack Y is equal to stack of X joined to Y. Come on, stick it in, why not? Okay, cool. So now we have this working, but now it's suggesting with the brackets. It'll probably fail. Yeah. Upgraded GHC is not very happy. Why not param blah return address here? Okay, so we're going to join params onto this thing. I hope this works. I really hope it works. Okay, so now when we come down to here, what we do is we load A from the CPU stack, where A is the stack pointer, and we were previously going back from it, but now we want to go forward from it. So stack pointer, then we're going to skip over the next two elements. Then we're going to go forward by the address we're looking up. So I might just fix the addresses to be 0 offset rather than 1 offset. So rather than saying param 1, I'll say param 0. It just makes this addition a bit easier. Okay, so now I need to go and fix my code in here. So some stuff needs to change. So we say call, we have 2 params, and this will now move forward by 1, so this should be 8. We're going to load param 0 and param 1. Then we're going to call 15. I better check these numbers afterwards. Then we're going to load param 0. Oh, sorry. When we say call, we need a number of parameters, which is 1. So this will now be 16. Then we're going to load parameter 0, do this. Okay. But all of these instances of call are going to be wrong. Okay, so what's this saying? It's defined this function, it's pointlessly doing 9 plus 3, calling add, that's 9, 3, add. Okay, so now we're pushing 5 and 2 onto this stack, and then we're doing call. So this has got 2 parameters, 2 and 5, and the address will now be 13 because we've added an extra instruction in, an extra operand in. And these params should be 0 and 1. Okay, load shouldn't be affected. Binary op shouldn't be affected. It just works. Return just works. Okay, so this is actually going to be called 0 and 4. Yeah, because the whole point of that is it's just checking return value. And that looks like it. Be amazed this works. We're 50 minutes in running the test for the first time. One failure. Functions calling functions, expected 9 but got 10. Getting closer, haven't quite got it right yet. Amazingly, everything else worked. Okay. Should be 9, it got 10 back, so let's see if we can look at what's happening here. Let me just check everything. So when we call A with 2 and 5, we get into here, so it should be 2 plus B of 5, and B of 5 should be 5 plus 2, which should be 7 plus 2 should be 9. Okay, so we push 5 and then we push 2. Okay, so this matters now. Previously, I was flipping these arguments round because I was counting back on the stack at the point which I called it. So the stack parameter function didn't contain the parameters that were passed in. So I was counting back into the stack parameter calling function to get those arguments, which meant I had to flip these so that -1 became this and -2 became this. But I don't do that anymore, so I can put the arguments in the correct order. Let's try it again. One failure. Expected 9 but got 4. Oh, even better now. Okay. So we've lost 5 somewhere. So what happens here? So we push 2 and push 5, then we call these 2 parameters. So we should pop them off and then put them back on again. Call number 8, then we hold. So we load parameter 0. Goodness sake. Then we load parameter 1. Typo in my opcodes. Okay. Then we call again, passing 1 parameter into this new address, which loads that parameter, pushes the value 2 on, so it'll be x plus 2, and then returns. So it should be returning 5 now rather than 4, and then we should add them together. Still not quite, but getting close. It's like the second add is not working. Oh, is that something wrong with our return address? It might be something wrong with the return address. Let's have a look and see. So when we call return, we go back to whatever it said the address was at the point at which we called it. So first of all, when we're calling it, the return address is the current position. So current position should be instruction after. Sorry, it's instruction after call, and it's 2 operands. So by the time we get to here, this CPOP should already be advanced beyond the point that it was at before. Yeah, it should be advanced beyond the instructions for call itself. So we just remember that as being the return address. That looks okay to me, but then we push stack pointer return address on, and then params after that. So reading back from the stack, it should be stack pointer, followed by address, followed by params. That might be the wrong way around. I'll have a look at that in a second. So when we get to return, we get a return result just by popping the stack. And the stack pointer is going to be loading from the current stack pointer Is that right? Or is it off by 1? I'm wondering. There's a current stack pointer, and you load that value, and then instruction pointer is the value that comes after that. So I'd like to see what the stack is at this point. So we can say vm.trace dot run trace the program, and the result, because this runs under IO, result comes from there this time. We can say result should be 9. And if I run it, and then I need to remember what the result of the trace is. Okay. So my pretty printing, I can do this better, couldn't I? So you print out the stack. Then we print out the stack pointer, then the instruction pointer. And blank line. So could we do something like print that, print, can we just make a string here? So stack pointer, something like that. Nope. Okay, I'll just keep doing these. Let the compiler worry about it. So we can say print the stack. Oh no, these are all on different lines. It's very annoying. Print the stack. Can we print a string? First of all, does this work? It does, but it suggests that okay. Does that make it any better? Okay, so if I do sp as some text, and then I should be able to join that onto that. Nope. Does this work? Nope. It's in fact not show that I want here, but something like text.pack. of show CPU SP. It is not. Wow, I'm making this really hard. It's not the thing I'm trying to solve right now. I'll come back and look at building this text in a nicer way later. We can say print SP, print the stack pointer. And then also print IP, print that. And I need to get rid of warnings because it won't compile. Okay, and then run it again. See that it's an easy to read. Not super easy, but anyway. So initially, empty stack pointer 0, IP is 0. Then stack is contains 2, stack pointer still 0. I made such a mess of this. IP is now 2 because we've gone over 2 instructions. The instruction, the operand. Then 5 and 2. Okay. Yeah, then this looks wrong. I think because we have 5270, stack pointer 0 and IP is 8. And then I think we're doing the call. Not quite. We're pushing 2 onto it next. Then we're pushing 5 onto it. This must be the call because now we jump. So the old stack pointer was 0. Return address is 15. I don't know what this 5 is. It should actually be 5 and 2, shouldn't it? So we got 0725, 0725. Then it seems to have split this. It's going to be off by 1. And why is the IP decreasing? I'm confused about that. We get 7. So I think the stack is wrong. So when we call something, I would expect it to be five 7052. What I think it should be. Well, that's actually because the stack pointer is 0. This 0 is actually here because the stack goes backwards. I forgot about that. Okay. So now we push the 2 on and we push the 5 on. That's okay. And then we call again. So we push 5 on and the 2 on. This splitting of it seems really weird. Because what it should really have done is, oh no, it's only one parameter passed into the next function. Okay, so it's pop 1 off, push the old stack pointer on, which is 0. The new stack pointer becomes 5, so 0, 1, 2, 3, 4, 5 makes sense. And the IP is 16. Okay. Then what happens next? It looks like it's done a return. It's too early. Because it I'd expect it to push 2 onto that and then add them together. It doesn't seem to be doing that. So the problem actually seems to be when you call the second function, it pushes, it sets the stack up correctly. I better check that 16 is correct. But it doesn't then push 2 on. It doesn't fetch 5 actually, so you should copy 5. Then it should push 2 onto that, and then it should add, so you should get 7, 5, 15, 0, and then it should return, and that's not happening. Okay, so, what's on the VM? No, back to the test. Okay, so, the first call is to position 8. It seems to be okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Makes sense. And the second call is to 16. So 8, 9, 10, 11, 12, 13, 14, 15, 16. It's a return. Out by 1 error. Okay, now that should be 17. Then we load the parameter, then we push 2, then we add and return. Should be 9, but got right 9. Okay, cool. That's just because that's the spec itself. We can just say vm.run program, turn off the tracing. Cool, success. Okay, quickly then. So, what have we done? Is this all just about calling? Yeah, parameter loading. It's always about parameter loading, I guess. So we can now pass params into functions. Let's push upstream. Cool. Okay, so we're done. Okay, so functions from a bytecode point of view seem to be working okay now. I still can't write recursive functions, but only because I don't have conditionals, so I can't ever make them stop. So that would be my problem. But everything else seems to be working okay. We can pass stuff in, get stuff out, have functions, call other functions. Good place to stop. Next week I'm going to come back to this and I will go back to the compiler, which is my original plan for today. But I'll go to the compiler, I'll look at adding high-level instructions for using variables and also for calling functions. So basically I want to make this work from a compiler point of view. So it'll be parsing it, first of all, generating some intermediate format, and then working out how to generate this bytecode from this high-level description. Cool. Yep, hopefully you can join me next week, and thank you for watching. Goodbye.